This is chapter 7F, and it's more about straight line graphs. So in this chapter, you'll learn to recognize the equation of a sloping line versus a line parallel to its axes, drawing lines from an equation, but also recognizing whether coordinates fit onto a line from the equation. So first of all, let's talk about sloping lines versus parallel lines. Okay, so anytime you're given that y is just equal to a plain number, basically what it's asking you to do is to first find the y-axis. Oh, there it is. Go up to the number 3. So 1, 2, 3. Now once at y equals 3, you're going to go ahead and draw a line going straight across, and there you go. That is your line. And when you have a y equals something equation, those lines are always parallel to the x-axis. So this symbol right here means parallel. So for example, if I had y equals 5, I'm going to go to the y-axis. I'm going to find 5. 1, 2, 3, 4, 5. I'm going to go ahead and draw a line straight across the 5. And there you go. That's what the equation y equals 5 looks like. Now, the question I always receive is, well, when you go to y equals 5, how do you not know to draw the line going up and down? Now think about this. If you draw the line going straight up and down, you can't really see the dot. In fact, it's right on the y-axis. It doesn't say anything. That's why it doesn't work. So even if I said, oh, y equals 4, and you go to y equals 4, and you draw your line straight up and down, well, it doesn't make sense because it's the same as y equals 5. So that is a what not to do. Now, anytime you have an x equals something, that line is always going to be parallel to the y-axis. So let's look. X equals 4. So first find the x-axis, find 4, 1, 2, 3, 4, and from here draw your line. And I have to go straight up and down in order to showcase it. So if I had x equals 2, so go to the x-axis, find 2, and go straight up and down. There you go. So the x, when x is equal to something, it's always parallel to the y-axis. Now, sloping lines are special. Anytime you see that x and y are in this equation, automatically know it's a sloping line. So let's just know that for now. So if I had an expression y equals 2x plus 1, I know it's a sloping line because x and y are in it. If I had x plus y equals 10, I know it's a sloping line, and it's because x and y are in it. And a sloping line is one that goes diagonally up or diagonally down. Okay, so drawing lines from equations. Draw one set of axes from 0 to 10. Draw all 3 graphs on the same axes to form a triangle. Shade in the triangle formed by the 3 lines. Okay, so if we do example A, there's 3 equations. Y equals 8, x equals 5, and y equals x plus 1. So first of all, I need to draw my axes from 0 to 10. So making your x-axis go from 0 to 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And your y-axis going straight up and down. 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. Then we have to draw the equation each line. So y equals 8. Go to the y-axis, find 8. 1, 2, 3, 4, 5, 6, 7, 8. Then from there, draw your line straight across. This equation is y equals 8. Then x equals 5. Go to your x-axis, find 5. 1, 2, 3, 4, 5. Then from there, draw your line. This equation is x equals 5. And then finally, the last one is a sloping line. And to do this, we need to have our table of values. And just to remind you, you are the controller of x. You can control what x is. X can be 1, 2, 3, 3 trillion, whatever you want it to be. But for the sake of the graph, since my numbers on the x-axis go from 0 to 10, I'm going to use the numbers between 0 to 10 to make this graph. And I like to just use the numbers, personally, 0, 1, 2, 3. Sometimes I might go 0, 2, 4, 6. As long as it fits my x-axis. If I tried to use 100, it would not work because, well, look, my x-axis only goes up to 10. Now that you know the value of x, because you controlled the value of x, substitute into your equation. So if the equation is y equals x plus 1, if x is 0, 0 plus 1 is 1. If x is 1, 1 plus 1 is 2. If x is 2, 2 plus 1 is 3. If x is 3, 3 plus 1 is 4. Now you have your coordinates. You can graph this. So 0, 1, 1, 2, 2, 3, and 3, 4. And then from there, using your ruler, draw a straight line going straight up and down. And from there, you need to shade in the triangle formed by all three lines. And it's this miniature little triangle right here. So at this time, pause and do part B. So let's do this. Y equals 6. Go to the y-axis, find 6. 1, 2, 3, 4, 5, 6. Draw your line. X equals 4, and label it. X equals 4. 1, 2, 3, 4. Draw your line. Use a ruler. Label it. And then finally, the equation y equals 2x minus 1. You control x, make a table of values. At least 3 coordinates. Your axes for x, the x-axis only goes up to 10, so don't use anything more than 10. I will use 0, 2, and 4 in this case just because I want to spread out my points. If x is 0, 0 times 2 is 0, take away 1 is negative 1. Oh, I might actually use one more coordinate. 2 times 2 is 4, take away 1 is 3. 4 times 2 is 8, take away 1 is 7. 6 times 2 is 12, take away 1 is 11. So graph. 0, negative 1. My graph doesn't have it, so I'm going to skip that for now. 2, 3. 2, 3. 4, 7. 4, 1, 2, 3, 4, 5, 6, 7. 6, 11. My graph will run out of space, but I think I can do this. 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay, and then draw your line using a ruler. Always extend your line long. And then shade in the triangle formed. And in this case, it's a very tiny little triangle. Okay, and finally, the last skill is, without drawing any diagrams, find out where each point lies on the given line. Now, in a set of coordinates, the first coordinate is always an x, the second one is always a y. So all you have to do is substitute it in and tell me if the statement is true or false. So if y is 5, so 5 equals, and then 3 plus 2. Is the statement true? Yes or no? Yes. So if it's true, that means yes, this coordinate is on the line. But if we try the second one, put in y for 4 for y and also 4 for x. So 4 equals 2 times 4 minus 5. Let's see if this works. 4 equals 8, take away 5. 4 equals 3. Is this true or not? No, this doesn't work. So in this case, no, this coordinate is not on the line. So at this time, pause and try out C and D. All right, let's see if this works. 9 for x, 1 for y. 1 equals 10 minus 9. True or false? This is true. So yes, this coordinate is on the line. 5 for x, 6 for y. So 6 equals 30 minus 5 times 5. So you must do that part first. 6 minus equals 30 minus 25. 6 equals 5. True or false? False. No. This coordinate is not on this line. So what that basically means is if you had a line, if it was on the line, the coordinate would be right here, sitting on the line. If the coordinate was not on the line, it would be somewhere else, like out here floating in space. And that's it.